सर अगर आप लोग आगे आ सकें काइंडली. The people sitting at the back, if you can please fill the seats at the front kindly. Bismillah ar-Rahman ar-Rahim. This is Hassan Malik, your host for the morning session. I would like, now our first speaker of the day is Professor Dr. Nadeem Ahmed Sheikh, who is currently Dean and Faculty of Engineering and Technology in International Islamic University, Islamabad, Pakistan. His teaching and research interests include the low-cost, eco-friendly energy technologies and related power systems. In addition, he has worked in building envelope energy modeling with context of BIM and recent advancement of AI, IoT, and smart electromechanical systems. He is author and co-author of over 110 technical papers in these areas. He will share his thoughts on the role of digital engineering in the sustainable integration of the current energy systems in Pakistan. Sir, please.
Bismillah ar-Rahman. Thank you very much. May I go to the presentation mode? Ladies and gentlemen, thank you for this opportunity, especially the ComSets Institute for arranging this seminar and workshop. I'll be talking about the role of digital engineering in sustainable integration of current energy systems of Pakistan, and I'll be taking the case studies from the building sector. Thank you for the brief introduction. And thank you. Okay, this is the overview of the talk. I've skipped this slide for my introduction. This has already been done. I'll be talking about some of the introduction, methodology, and results and conclusions. Moving forward to the problem at hand. Sorry. Buildings, like the Honorable Minister has already set the tone for today's talk, is how we can save electricity and conserve the resources we have. Starting from the light bulb he talked about. Building as a whole includes a number of things. We have fans, bulbs, and other appliances which are present in the building. Today, in this morning, in this hall, a number of people are sitting, and everybody knew what is the event today. But the one thing which does not know what is happening in this hall is the building itself, because it is passive and it does not understand what is happening, and it cannot really accommodate any of the demand which is taking place in this hall, because there is no sensing network which is available to tell it that this is the event which is going to happen, the outside climate, the inside environment, what sort of activity is going to happen inside. So all of this is involved in the building sector, and it is related to a number of things, whether it is related to the green, for example, the World Green Building Council has linked the building sector with different SDGs which are available. At least I can map with 9 SDGs here, starting from SDG 3 to SDG 7, 8, 9, 11, 12, 13, and 15 and 17. Thank you. Is it working? Okay. So, for example, the building sector can link the performance of the people employees with the good health and well-being, and it is definitely the affordable energy which is we are talking about, and the work environment, and economics is already linked with the decent work environment. And most importantly, the infrastructure we are talking about, because as we talk about more and more buildings being grown up in the urban centers of developing world, for example, Pakistan, in the new scheme, that the Nia Pakistan housing scheme, we are building more than 5 million housing units. So those units are going to create more energy demand, and what sort of energy demand, how we can fulfill that thing which I'm going to talk about today. And then we can link this with the sustainable communities and cities, and then the basics of the circular energy that can be linked with the climate action and other sustainable development goals we are talking about. Already here we can see that the building sector is already linked with the emissions which we are producing in the environment. And if you look at the bigger emitters in the world, for example, China and Russia and US, they're producing already a lot of metric tons of carbon dioxide in the environment. And if you can see that the lesser blue color, those are the south and the growing economies across the globe, which are going to convert into more populous metropolitan and urban centers. And once these metropolitans are getting into built up structures, then the emissions will rise there as well. One thing which I like to talk about is the sick building syndrome. This is the kind of syndrome we get in the airtight buildings, where the different kind of items can, for example, in the COVID, we've seen that the virus can circulate within the building if it is airtight. So that kind of items, they are also related to the topic I'm going to talk about today. I think there's definitely some issue with this. Okay. Sometimes it works. So here is the problem at hand, that the world average we are talking about in the building sector, it is consuming around 30% of the electricity. I've put the result from the peak COVID because COVID has changed this statistics a lot, but that is probably and hopefully not a very long duration of period of time, but it is going to impact the overall consumption of electricity in the building units. And on the other hand side, we have the Pakistan average from the year 2018 again, which is pre-COVID. And this data is picked from the Economic Survey of Pakistan. And we can see that about 55% of our total prime energy consumption is in the heating and cooling, which is taking place in the built-up structure, whether it is commercial, residential, or other use buildings. So if you, on a typical day, if you're producing 20 gigawatts of electricity, and 55% of the total consumption, which is about more than 5 gigawatts of electricity, is going to be utilized is just for the cooling and heating of the buildings itself. So imagine that we can save only 1% or 5% of this energy. That can create a big impact on the social fabric. It was the same thing which the Honorable Minister was saying, that if we can save 300 megawatt of electricity by just conserving something, then we can replace the Chashma nuclear power plant there, one of the generation unit. So this is a very big number actually, if we can save that. For example, one key example which I give normally in my talk is about the lead and lag issue. For example, in this building, before everybody could enter in this room, there was air conditioning, for example, was on if it was peak summer season. And once we leave at 5 o'clock, the air conditioning will be shut off after everyone is left. So, and we know that before entering here, there is a lead period, and when everybody has left, there's a lag period. That amounts to about 7 to 10% of the electricity consumption in different commercial buildings. And that's a huge number, actually. That's not a small number. So that is a huge number which we are going to just consume based on the human intervention of lead and lag. And imagine that if this building can sensitize itself and make itself more active, then this sort of lead and lag can be lowered. So why we are interested in buildings? Because they offer what we call as the thermal comfort. We all are cozy and comfortable here today because environment inside the room is about 23 degree to 25 degrees centigrade. And we have different, our outfits are differently arranged. For example, if we have a gathering today where we have formal dressing and informal dressing, and if it was a gym or a hospital, the thermal requirement for the comfort would change. For example, if it was a hospital ward here, and we have average age of like 60 plus, then this might be chilly and it requires some heating. But today, most of the young people are sitting here, so this is comfortable here. So thermal requirement operates between 20 degrees to 27 degrees, depending on our sensitivity and the kind of clothing we are doing, the metabolic rates we are generating, the different air temperature, air speed, and humidity. So that is the kind of input which is required to ascertain what sort of comfort condition we are here. And it's linked with everything. The thermal comfort is going to affect our productivity. For example, in office environment, if we are not comfortable, if it is chilly, we can't produce. And if it is too hot, we are too sweaty and our palms will be sweat. So these kind of things, they are one of the main pillars of the air conditioning, that how we are producing the indoor thermal comfort. So in the building envelope, like I talked earlier, that it's not only the room itself, it is the complete building and the micro climate which is surrounding this building. So if it is 20 degrees outside today or 24 degrees outside today, it is thermal comfort outside, but yet we need some sort of air conditioning to keep it comfort here inside, because each of us, we are generating, we are just working like an engine, and we're producing heat here. And there are different other external factors which are influencing, for example, the solar energy, which is already available, and it is going to impact, for example, it is going to heat up, or it is going to, if there is, it is raining outside, it is going to cool down the external environment. So there are different ways of restricting the heat from entering or leaving the buildings. There are some prevention techniques, and there are some modulating techniques. So for example, prevention techniques can be that we have thermal insulation on our windows we are having here. And there are the modulation techniques include different, for example, integration of the phase change material in the building structures. This is going to be something which I'm going to talk about later in the day. One of the important things is the way we can use or harness this energy, which is freely available outside, for reduction in the total energy footprint of the building sector itself. So like I said, there are several ways of doing that. First and foremost that comes in our mind are those active systems which are installed here. So they are air conditioners which are present here, which are active systems. So if we don't feel the comfort, we can switch on the air conditioners and make the whole system, a whole environment comfortable for us. And there are some other ways of doing it. There are some alternates. For example, in the right in the middle, there is some famously called Lahori cooler, or the desert swamp cooler, which is commonly used in our urban centers in low lying regions, for example. And there are alternates which different research groups are working. For example, one of my research projects is related to the desiccant cooling, which I'll talk about later in these slides. And there is something which we call as the passive way of designing the building itself. For example, in the center, you can see a building which is having a solar chimney installed there. A solar chimney is a very simple concept. If you look at that, the solar wall is receiving the most of the radiations, and that radiation is then trapped into some sort of phase change material. So by phase change material, I mean that material which can change its phase from solid to, for example, liquid. Now, in that process of thermodynamic process, we don't add the temperature increase. So that sensible temperature is not going to change, but only all of the energy which is available outside can be converted and stored into some sort of conversion of the heat to some chemical energy, which is in the chemical itself, in the PCM. And that energy which is stored, that can be utilized later on. For example, that prevention of heat entering into the system is actually reducing the thermal load of the system itself. So just imagine that that the whole of the solar wall is stopping the solar energy to come inside. So a lot of heat which is going to come inside is not to be removed from the air conditioning system. So that is prevention of the heat from entering. And in the other way around, in the heating season, we can store the excessive heat which is available during the daytime and harness that in the evening and the night to get the heat by converting the liquid back to solid and using that for solar heating. So this is the kind of idea we can talk about, and this is the free cooling which is available, and this can be easily integrated into the building sector. There's an example which I'm showing there in front of you, that the solar wall can be built, which can be, and a number of structures we see around in the urban centers growing up. They are basically, if you look at the commercial buildings, they are using the glass wall in front of them, and that is aesthetically, because that is part of the facade we are using, and that is aesthetic, as well as it can be used to keep the PCM behind that solar wall for there. It can save the excessive energy which is present. Going back, so if you look at the top, the way we have defined, and this is the talk which I'm going to focus on, is that the system, then the physical model, the data engineering, which is the most important part, that how we can integrate this kind of idea. Because once we build the building, it is no longer easier or financially viable to build such a structure. which can be used as a solar wall, because it is passive way of stopping or preventing the heat to enter. So this has to be embedded in the design phase of the building itself. And this is where the building information modeling, and one of the extension of building information modeling is building energy modeling, that is coming into play, that how we can use different ways and designs to integrate that passive way of storing the heat in the building. And the design step includes from the physical model to the data engineering, and then the sensitivity analysis, and then some sort of optimization will be conducted, so that we can calculate how much and what size of thermal battery we are going to use to keep this kind of system to work. So so here's a physical model which includes a number of things. For example, in a typical house, we have a solar chimney here installed on the left-hand side, and which includes the building model and the PCM model. So the building model includes a number of factors. So what sort of activity is going on, what sort of the solar flux is available, what sort of ventilation is taking place, and what sort of activity people are performing, and what are the appliances and sources which are present inside the building. So those kind of things, they are going to dictate what is the thermal load which is going to be presented. So this is very important because this is where the most of the stochastic modeling comes in, that how to have an assessment that how many people are going to come today in this conference. And conference does not take place every day. So this most of the most of the days in the year, this room is empty, for example. And it is probably working for 20 or 50 or 70 days in the whole of the 365 days. So the modeling itself is very important, that we can accurately predict, or we can have an assessment which is reliable in terms of the data which is available for this model. So if you look at the network diagram which I've shown here, then this is the network diagram for the heat which is infiltrating into a typical house. So which includes a number of factors, which includes the overall heat transfer coefficient, which includes the from the infiltration from the roof, from the windows, from the building surroundings, from the weather which is present, from the solar irradiance which is coming. So these are the kind of network of the heat which is infiltrating into this building. And accurately modeling it is very important. And for the solar chimney itself, so that model of the building that comes as an input into the whole system. I won't go into the mathematics here for the sake of the general public, but I will indicate that the overall balance at the solar wall includes a number of things, which includes the load from the building, which includes the PCM itself, how it is going to behave, what is the transition temperature, for example, how much of temperature it can, how much of heat it can absorb and convert its thermal mass from solid to liquid. So that amount of the latent heat is important. And then the energy balance of the liquid when it is converted into liquid from the solid, and the energy balance at the glass surface which is present at the outside. So this is the kind of the thermal modeling which is important. And once the model is there, there are a number of factors which are present, and those factors, they are going to be varying. For example, the solar irradiance which is present outside, it is varying all the time and throughout the year. And because it depends on what is the, for example, if there are cloud shades outside, so the solar irradiance is going to change, and it varies every hour, every day, a single day of the year. So that is the kind of modeling which involves, and how to predict this is important. So if you see that we have gone through this whole process of modeling the system, and we have identified some of the key variables which are important. For example, the length, width, and diameter of the solar chimney, the transition temperatures and solar irradiance, the wind speed, for example, the heat capacities, the latent heats, the fusion temperatures, for example, and some of the output parameters. For example, there are 3 output parameters I'm looking at. How much of the air change, ACH represents the air change requirement per hour, and then eta is the efficiency of such a system of installing the PCM, and psi represents the amount of CO2 emission reduction we are doing. So this is now a kind of a parametric optimization method where we have input parameters, constraint parameters, and then we have some objectives which are present here. So these are the three objectives we are looking at. And in this assessment, for example, here I'm presenting, we are looking at how much of these parameters are going to influence these three outputs. So for example, the efficiency is highly linked with the latent heat, which is going to be absorbed within the PCM. Now, this is contributing more than 14% in the overall efficiency paradigm here. And the emissions, for example, the irradiance, for example, itself from the solar irradiance is going to play in the sensitivity analysis around 22% part in the solar analysis. Next slide. So once we have identified and the different data set is available, if you go back. So this is a typical picture which probably more familiar with different neural network people, and how we train. I've just identified some of the input layer parameters, around 7 or 8 input parameters, and the 3 output parameters which I've identified. For example, the efficiency, the CO2 emissions, and then the annual the air change per hour. So these inputs and outputs are going to be interlinked through a neural network. This is a deep learning method which requires the normalization, and then the training data, and then the validation data, and the testing data. So this is the typical way of running the whole optimization cycle. So because based on this optimization cycle and the input parameters we are looking at, we can train the model to get the optimal values of the outcome. There are different genetic algorithms which are available for this training, and this data for the whole year can be utilized to the objective optimization. Now, this is there are 3 optimization or 3 parameters we have looked at the output. One is the power, is the efficiency. Third is we have identified CO2. Now, get them all together because there are multiple objectives. So it's not easy to have one outcome of this whole system. If it was one parameter optimization, we would have got one outcome. But here we have a multiple set of outcomes which are available, which are all optimal sets. But we need to look at what is the most closest to the desirable outcome we are looking at. So the ideal solution is important, and the non-ideal solution, which is what we don't want actually. So whichever the solution which is closer to the ideal solution, we use different ways of calculating it. For example, here TOPSIS is used to calculate which one is most closest to the ideal solution we are looking at, and based on that ideal solution, we can predict what is the outcome we are having for the optimal solution. And once we optimize that, we can see that this optimization then can be converted to a global canvas, not only on the Pakistani canvas. We can have data from different cities from the globe, and we can evaluate at what location we can have different sort of optimization of the parameter. For example, here we see 2 different parameters we have selected here. One is the air change, and the other is the CO2 emission. And we can see that the optimization can tell us that how much of this model can be beneficial at different parts of the world. And in the south, for example, we can see, including India and Pakistan somewhere, that this emission can be significantly lowered if we can integrate the solar chimney in the housing of our housing sector, for example. The second case study, which is on the active systems. Active systems are those systems which are not embedded in the housing design, but also are working at the demand, and it is responsible for most of the air conditioning we are doing. And we know that the typical system we look at here, they are as efficient as, like, for example, with EER, which is the energy efficiency ratio of around 1 to 3. So, for example, we have 3-star rated air conditioning system these days, which are considered very highly efficient, but they are consuming one unit of electricity to remove 3 units of thermal heat. So, and the unit which I'm talking about here and presenting here is what we developed in our lab. It is basically a desiccant based system, and it is having an EER, which is the energy efficiency ratio, of more than 30 to 50. And if we integrate solar energy in this, solar thermal energy, we can get to even higher than 100 EER, which is comparing to the conventional system of 1 to 3 EER. This is significantly higher. So this involved a number of items and different sets. which one important item here is the desiccant wheel. Now, as I talked about the thermal comfort, desiccant wheel is the one which is going to remove the excessive humidity from the air. For example, in the rainy season, in the monsoon, we have a lot of desert coolers failing to work. And one of the prime reason is that because they are using the direct evaporation, and because there is no capacity in the air to have more air vapors into it, so they don't work. So we have installed a desiccant wheel here, and that works in a lab to show you that how we can efficiently control the air quality compared to the conventional system we have. And once we integrate that with the renewable energy, so renewable energy is that we can use the solar thermal. For example, the flat plate collectors, they can be integrated directly into the system. Why we need this solar energy? Because desiccant wheel cannot work independently, it has to be recharged. So it works in a cyclic manner. So once it removes the humidity from the air, it has to be recharged, and the humidity has to be going back to the environment, and that requires heat, and that heat can be tapped from the solar energy. And here we can have solar energy directly coming from the sun using the collectors, or we can store it in a solar storage tank using a PCM material, which can be used in the evening and nights for recharging the wheel. One important aspect of this whole integration, I'm going to skip because I know that I'm running short on the time, is about because part of the heat we are going to use, it can be used for multiple purposes. One important aspect of this dedicated air conditioners we have is that it can only produce thermal comfort in this room, and the outside of this unit is going to produce more heat at the outside. If you look at the outdoor unit, it is producing heat because it has to reject heat at the outside. The system which we are proposing here, integrated system using the desiccant wheel, it produces very low heat or very low carbon footprint at the outside. And in fact, that outside environment or that outside air can also be utilized because that is humid air, and that humid air can be utilized in different locations. For example, we can use that for example, it's in a bigger mall, we can use that outside humid air for getting the thermal comfort of vegetables and fruits and poultry and other meat materials. So that is the kind of idea which I'm presenting here. So it's not only that the thermal comfort is present inside that. So if you look at the figure here, the thermal comfort is in the blue region there for the human, but for the pets and different vegetables, the thermal comforts are in the other figures we can see they are not at the same location in the psychometric chart. So we can use a different rejected air or the humid air for thermal comfort of different species and animals even. And here we have shown that how data engineering can help in predicting that where the human thermal comfort is present and where the producer and communities, the thermal comfort can be used, and different ways of controlling it using the optimization schemes we have just talked about. And again, this kind of analysis can be globalized using this methodology, that how we can use the predictions and models to get the assessment across the globe. So we have picked around 30 cities across the globe, and we have done calculations that how our system can be used to produce the thermal comfort for human as well as for the different producers. And we have seen that that this works. If you go to the next slide, that it can be adapted at different locations, and specifically those locations which are near to the equator, where we have high heat zones, and we can see that the energy efficiency ratio can go as high as 32. That is significantly 10 times higher than the conventional system, where we can use this kind of system. And we can see that Pakistan is covered there, and a lot of the central Middle East is there, which is one of the high producing area of this CO2 emissions. And similarly, the low levelized cost of electricity to produce this thermal comfort is significantly low in desertous areas compared to the conventional system. For example, in the south, if you install these air conditioning systems, they are expensive and they are least efficient. But if you go and with the desiccant based system, they are much more efficient in the desert environment, and they have a very little water footprint. And this is the calculation for the water footprint. And we can see that because in the desert areas, water availability is also a challenge. But not only they are efficient in the desert areas with the low levelized cost of electricity, but also they have a very specific and reduced water footprint, which is significantly low compared to the conventional evaporative cooling we are using. So instead of using the evaporative cooling, we can use desiccant-based cooling, which can be much more helpful and useful for these environments. So this is what I have to show you today. If there are any questions, I'll be open.
Okay, my question is that in the first, you provided that solar chimney would be installed, integrated to a grid, to a building to overcome that efficiency reduction, whatever. So my point is that this, have you done any comparison with the conventional solution which is used for the passive cooling? That is the first question. Because it's,
so I talked about the passive cooling as well as heating application. So removing or preventing the solar energy to enter into the building is also a cooling part. So instead of having more influx of energy coming, we can actually prevent it from entering it. And that's something which is important actually. Because that reduces the electricity load. For example, if you have an electricity load of 10 ton, and if you reduce 2 ton or 3 ton of the air conditioning requirement, that is saving.
But how much costs that will be occur on your solution? There's no such comparison.
So, like I said, using the passive systems, they require inbuilt into the building design rather than if you retrofit it. So retrofitting is much more expensive because the buildings are not really exactly designed. So, for example, in the new building, for example, the BIM can easily integrate how much of cost and life cycle assessment, that how much of the saving it is going to do upfront cost and the saving it is going to do on its lifetime. We have done that. We haven't published it as yet, so I'm not sharing that slide here. So, but we have done that assessment.
Okay. Second question is about your solar air conditioning. You just said that. So my question is that since there must be a thermodynamic cycle in that whatever solution you have proposed. So what is that? On which thermodynamic cycle that basically that is being used?
I don't know what is the background of the people sitting here, so I kept it general. So we basically the desiccant air conditioning system. It involves there are different cycles, stages involved in it.
Yes.
We have used the Massett cycle, which is basically a new cycle of going along horizontal on the psychometric chart. So instead of adding the moisture, we are keeping the moisture at the minimum or equivalent to what is present outside. So that is what we have done.
What would be the working fluid in that?
Sorry?
Working fluid.
Working fluid is air, actually. There's no refrigerant involved in it.
Thank you.
Thank you. Any other question, Mohammed or something? Yeah, regarding the phase change material, that's an important question. And the variables which I showed you here included the heat capacity and latent heat and the fusion temperature. So in different parts of the world, it is, for example, if you go to Murray, we have different thermal requirements. And if you go to Multan or if you go to Karachi, you have a different thermal requirement. So one PCM cannot work everywhere. So you have to select what is the most appropriate PCM. And that depends on the fusion temperature you have, that at what temperature you want the heat to be stored in the material itself. So for example, in South, you may start at 30 degrees or 35 degrees to start storing the heat. But in Murray, you might have a higher temperature to work with because you want some heating to go inside as well. So the different zones have different PCM selection, and that is one of the parameters we have kept. That what is the optimal? That's why I showed you the global projection. It's not same for everybody. At different parts of the globe, it will be different. And there has to be some selection criteria or method. And that's what we are presenting here. That if you have this methodology, you can put in the numbers and you can get what is the optimal solution for that specific region, for even that specific home, because we would be having the orientation as well as the local flux which is coming on your home. That is also part of this algorithm, so that it can predict what sort of PCM is best suited for that kind of location. There are different PCMs which are available. NaNO3, for example, is one of the PCM which is available. Different, even the ice is a PCM. So if you have ice coming and if you go to buy some gola from ready se, so you will see that they're using a PCM. Actually, they put some salt on it, and it keep it for longer duration of time. So that is a PCM essentially. Any other question?
I checked the cost for the solution. Have you checked the breaking point where your proposed solution was?
Yeah, that's a very important question, and talked about EER, which is the energy efficiency ratio. And if you can compare like for like system. So you compare your system with the conventional system we have. So the EER, the energy efficiency ratio, which means that how much of electricity you are putting in to get thermal comfort. So if you are spending 1 rupee and getting 3 rupee thermal comfort, let's in a very layman term, the system which I'm talking about, the solar air conditioning, if you put 1 rupee, you are getting a thermal comfort of more than 30. So I know the capital cost will be higher, but if you calculate the running cost or the overall cost on the lifetime scale, for example, 5 years, you will have a much bigger saving compared to the conventional system. We have done that. We have, alhamdulillah, we are completing a TDF from HEC as well on this, which is a technology development fund. And we are in a phase of successfully launching it in this summer, inshallah, as well, the solar air conditioning. Any other questions we have? I think after time over. Thank you very much. Thank you for the opportunity.
So this was Professor Dr. Nadeem Ahmed Sheikh Saab. It is our privilege to have Dr. Tosif Anwar. He is working as assistant professor in Department of Physics, University of Lahore campus. His areas of specialization and interest is energy storage materials for lithium ion batteries. Till now, he had published 26 scientific research articles with a cumulative impact factor of 150. He will share his thoughts on lithium ion batteries as energy storage device. Sir, please.
Assalamu alaikum, everyone. Thank you so much for invitation to ComSets and such a nice introduction. Today, I want to talk about energy storage devices. So let's start. These are the content which I share with you people. Introduction, energy storage, and what is energy storage and devices. Next is lithium-ion battery. We will talk about lithium-ion batteries. My research work. I worked in Comsat University Islamabad, and I have some contributions, so I will discuss this also, and I will conclude it, inshallah. As previous speakers discussed this thing, that most of the energy, or you can say that major part of energy dependence is on fossil fuels. In these fuels, coal, gas, petroleum, these are main part. Major part is that one. Okay, this major part have a little bit problem with it, and that is that they have limited sources. They are expensive. Pakistan is paying a lot of bills for their fossil fuels. Second, the environment effect. This is Lahore. You can see that Pakistan is less carbon dioxide emission countries, and still this is the situation of Pakistan. And you can imagine the situation of other countries, like I stayed in Beijing in 2012 to 2016, and condition was worse, very bad condition. So this is a very bad impact. Next is that global warming. These are things exhausting our earth. So what is its solution? We have to move toward solution. Its solution is that we have to move renewable energy sources like solar, wind, hydropower, biomass, tidal, geothermal. These are the renewable energy sources. They have very less impact on environment. They are abundant. So we have to move toward the renewable energy sources. You can see in this slide that how much energy we are using, world is using. In 2020, you can see that we are producing 24% from coal, 38% of our energy we are producing from petroleum, 27% from natural gas. So we are totally depending, at that time, we are totally depending upon fossil fuels. We cannot omit these sources. Of course, we cannot omit these sources, but we can reduce their part, and we can enhance the part of renewable resources like hydropower, renewable resources, nuclear power. We have to enhance them. For next generation, we have to enhance them. Okay. Pakistan is always in energy crunch. You can see that in 17 and 18, the data, we produce 85,000 gigawatt hour. This is our production, and our demand was 1,17,000 gigawatt hour. Similarly, in 2018 and 19, you can see that our production was less and our demand was high. Pakistan, the share of thermal in Pakistan is 63%. We are also producing from renewable resources like hydropower, and that is 26%. But our share of renewable resources like biomass, solar cells, or other energy renewable resources is very less, that is 3%. As compared to if we look in our region, China, India, other countries, you can see that China is producing 131 gigawatt from the solar cells. Similarly, you can see India, this 18.3 gigawatt, this is from solar cell they are producing. Pakistan is here, the lowest. Okay. So we have to move toward the renewable resources. Okay. This is a news, so I add it because till now we are using renewable resources that are 4% of our energy, which are we are producing. But government want that we have to enhance it to 30%. Okay, and this 30% is from wind, solar, and biomass. For this, automatically, it have some needs. Okay, it have some equipment in which we can store it. So we have to move towards storage. Without storage, we cannot store it or we cannot utilize them. Okay, because these sources are intermittent sources. You need a storage device to store energy from solar cell because they're time dependent. Light have specific time. Wind energy, they have time dependent. Even nuclear, they have also fuel dependent. Okay, and you have to store these energy. And these are intermittent energy. Okay, then you can give it to society or you can give it to this country. In energy storage devices, when we talk about energy storage devices, then we have two types of the devices. One is supercapacitor and other is batteries, rechargeable batteries. And rechargeable battery, because supercapacitor charge time is like they can store for very less time. Okay, we need a storage device which can store energy for longer time. So we will talk about batteries, just batteries. Okay, in batteries, lead acid batteries, nickel metal hydride batteries, lithium ion batteries. These are the batteries which are storage devices for such like systems. So we just will talk about batteries. Then lead acid battery, they have captured the market. Till now, all Pakistan industrial setup is for the lead acid batteries. We are producing just lead acid batteries. Okay, but nickel cadmium we are also purchasing from other countries. Similarly, nickel metal hydride we are purchasing from. Lithium ion battery, we have no installation of the lithium ion battery in Pakistan. Okay, these are the advanced battery which we need. We have to move toward lithium ion batteries. If we want to store a lot of energy and want to provide a lot of energy, then we have to store. We have an efficient storage device, and that is lithium ion battery. Okay, you can see its energy density, lead acid energy density is very low. Similarly, other energy densities, they have also other disadvantage which lithium ion have not. Okay. Lithium ion battery won Nobel Prize in chemistry in 2019. This was John Whittingham from USA, John Goodenough, Stanley Whittingham from British. He was British, and Akira Yoshino. He was from an industry, not academia. And they three people won Nobel Prize in the lithium and field of lithium ion battery because they wireless the society. And now you are seeing that electric vehicle is moving toward the lithium ion battery side, and they are going towards storage side. Okay. Pakistani industry depends upon the production of Pakistan storage device is just lead acid battery. This is the part of different industries, AGS, Exide, Volta, Phoenix, Millat, and so some we import from other countries. Okay, and this is the part. This all is energy storage devices in Pakistan, which we are using. We are manufacturing. Okay, and we are using that one. We also have lithium ion battery or other type of the batteries, but we purchase them from other countries. These are imported and everything. So we have now still now we have not any industry of which is working in the field of lithium ion battery. Okay. Lithium ion battery. From here, I will move toward our research side little bit. I will discuss little bit about it. I will not go deep, but I want to discuss these things. A lithium ion battery have advantage on different batteries, like its advantage. It have a higher specific energy and density. Similarly, it have self discharge. If you put it for 1 year, it discharge very less. Okay, as compared to other batteries. Similarly, higher coulombic efficiency and energy efficiencies, broad temperature range is broad at long temperature range from 0 to like this 35 or 40 or 40 like that. Okay, it have not memory effect. This is a concept that if you there are few batteries, if you charge them, discharge them half, and once again then you put them on charging, the next time they will give you that half charging. It will forget the remaining half. So this is memory effect which it have not. Similarly, the high operating voltage, its operating voltage is very high. It have also some disadvantage, like some limitations. You can say that there is no chemical mechanism which can control the overcharge. Okay. If cell is overcharged, then you have to introduce another battery management system that is work in electrical engineering. Okay. and they use it, and this will manage this all system, and they can control the storage setup. Safety is a big issue till now. Till now, it is a big issue. If it have some few years back or last year, you heard that there was a fire in Hafiz Center, Lahore, and it was a little problematic for the fire brigade and all of these people, and they cannot finish it because this was a chemical fire. So this safety is an issue. It is temperature dependent. If temperature is very high, then it affects its performance. If it's very low, it affects its performance. Electrode materials are not mature yet, so still it is working. Different scientists are working on that in that field. Okay. This is the schematic diagram of lithium battery. It has 3 port: negative electrode, positive electrode. Negative electrode is mostly used lithium titanate or carbon graphite. Okay, and this is electrolyte. Similarly, this is cathode. And these three areas, a lot of scientists are working in these 3 areas: anodes, cathodes, and electrolyte. Similar, some people are working on its design, like the separator, which we use to separate these 2 electrode, cathode and anode. This is the history of battery. Okay, battery was introduced in 1859. That time the battery was lead acid battery. Okay, and in future it progressed to nickel cadmium batteries, nickel metal halide batteries. In 1991, Sony Corporation introduced first lithium-ion battery. Okay, and that was first lithium-ion battery which Sony Corporation introduced in the world. And after that, the replacement of the lead acid battery is moving toward the lithium-ion battery. Okay, now lithium-ion battery is on that stage. Okay, we are here now, and they use different nanomaterials for lithium-ion battery. Okay, and these batteries are more efficient as compared to this Sony batteries. Okay, because different chemicals have been changed, different anode materials have been changed, different things are new in it, and now battery is more efficient. Even this battery is utilized in electric vehicle, for storage, for different things. And next is post lithium-ion batteries. In our next generation, we'll see the batteries of the lithium air battery. Okay, this will be advanced battery, very advanced battery with very high specific capacity. Okay, and with very high safety. Similarly, these are the lithium organic batteries. This is the future of the batteries. Okay. Here I discussed that lead acid battery have a lot of part of lead, this lead battery, but its capacity is very low. If we gravimetric energy density, watt hour per kilogram, this is very low. Okay, first generation lithium-ion battery was that. Okay, and now we are here. We are using this one. These are post lithium-ion batteries, in which sodium-ion battery, lithium sulfur batteries, solid state batteries, and lithium air batteries. These are all involved, but these are in future. People are working on this and this. Okay, this is just for the reason that if lithium deplete, then we can move toward the sodium ion. Okay, so we achieved this, and we are trying to enhance this thing with materials. We are using different material like anode, cathode. Different people are working on an anode material, cathode electrolytes, and we are making it more and more safer and more better and more heavy with more capacity. Now you can see that your mobile have, I think so, 5,000 mAh. Okay, and it works for 1 or 2 days. Okay, so same this thing is with this battery, but on advanced level. We use just advanced materials. Next batteries, this is the post lithium-ion batteries. These are all post lithium-ion batteries, which are not in market till now, but they will be in market. Okay. Not very soon, but soon. This energy demand is increasing. This is for cell, annual cell energy demand. This is increasing day by day, every year. In 2005, this was totally dominated by lead acid battery. This was demand, and this was totally led by lead acid battery. It was the monopoly was lead acid battery. It is the monopoly of lead acid battery is decreasing now, and this lithium ion battery is increasing now. In 2030, the 80% part will be lithium ion battery. So Pakistan have to move toward the lithium ion battery. Our industry have to move toward the lithium ion battery. You can see this region that China is leading in lithium ion battery. India is progressing very quickly in this field, but Pakistan is still, there is no lithium ion battery industry in Pakistan till now. If we want to go toward better storage, we have to move toward the better batteries. This demand is increasing. You can say this is also data from this European Technology and Innovation Platform report. You can see here that in 2030, what will be the demand of energy storage? This will be 221 gigawatt hour in 2030. So this demand is, I want to show that the demand is increasing, and we have to move toward better energy storage. Yes. This is for electronics, 69 gigawatt hour, and this is for battery, electric vehicle. This will be for electric vehicle. Okay. So in future, you will see that your electric vehicle will work on lithium ion battery. Okay. Similarly, if we see the region-wise, you can see that in 2030, the demand of the China will be most demanding country in the field of lithium ion battery, because they are leading to the world. Now they are leading to the world. Similarly, we are in the rest of the world. Okay. Here, I want to share my contribution in this field, and I work in anode material for lithium ion battery. In anode material, there are two types of the anode material which are used in lithium ion battery, and these are graphite and lithium titanate. These both have some specific problems. Okay, so I try to solve this problem with the help of this titanium dioxide. On next slide, I will show that why I use titanium dioxide. Because its specific capacity was comparable to, you can see that lithium titanate has very good safety. Safety issue you can solve with the help of lithium titanate. Okay, and capacity, carbon have a good capacity, 372 milliampere hour per gram, the capacity of graphite. We have to, so I try to do this, that I also want to enhance its specific capacity, and I also enhance safety. So I use this structure in nanomaterial, and I achieve this thing, and its capacity is 336, which is near to 372. You can say it is near to. You cannot say that 100%, but near to. But it's better than lithium titanate. But its safety is more better than lithium titanate. Okay. Its operating voltage high. Graphite operate at 0 degree centigrade, zero potential window, but this is its potential window is 1.75. Okay, and lithium titanate is 1.5. So it is near to lithium titanate. So its reaction with electrolyte is very less. So it is more safer as compared to other this graphite which is used in lithium ion battery nowadays. Yeah. Next thing was its pulverization is low. The main problem with the battery's life is its pulverization. When lithium goes in some material, because it intercalate, it did not react, it just intercalate. It intercalate and come out, it produce pulverization. इसका मतलब ये है कि ये जो मटेरियल होता है ये फैलता है, जब उसमें से लिथियम बाहर आती है तो वो सिकुड़ता है. ठीक है, इसकी वजह से इसके कॉन्टैक्ट टूटते हैं, जिसकी वजह से your battery works for 1 year, 2 years like that. So if you want to enhance its life, you need to use a material which have longer life. Okay, for better batteries we need longer life batteries. So we use this. Titanium dioxide have low pulverization, is 4% pulverization, while graphite have 30% pulverization. So your battery work for 1 year or maximum 2 years. Social issues, you can see that it was low cost, naturally abundant, environmental friendly. This I'm talking about titanium dioxide. Okay, I work on titanium dioxide. Titanium dioxide different allotropes. In one dimensional, it have nanotubes, fibers. nanorods. In 2-dimensional, it have nanoflakes, hollow spheres, like petal-like nanospheres, nanosheets, some microns, 3-dimensional, hollow spheres, and porous materials like this. These are the props. I select titanium dioxide nanotube arrays for my research because they have high specific surface area, volumetric expansion was very low, even less than 4%, short lithium diffusion path, and it is additive-free anode. After making this material, we have to use it, some additives, some carbon black, and then we use it as anode material. But this was grown on this substrate, so these are additive-free anode materials. I did this different projects. I just want to tell you a little bit about this. I will not explain it a lot. This is the anodization method, 2-step anodization method. In first method, I grow titanium dioxide nanotubes, and these on this substrate, these are grown. I peel them out, and there is footprints of these nanotubes. And then second anodization, I grown these titanium dioxide nanotubes, and you can see in this figure that this is the nanograss. In first anodization, when we did it, this was nanograss and it was not clean. So to clean it, we peeled them out, and I used second anodization. And in second anodization, these are the footprints. This is the second anodization. After second anodization, we have no grass, and we get very clean titanium dioxide nanotube. This is their top side, and this is their lateral side. Okay, these are the nanotubes I grown, and I use them in lithium-ion battery as anode material. You can see that I use them in amorphous form. I use them in after annealing in anatase form, and after that I select that I will choose this lower capacity material, which is anatase. It's anatase form. So next work will be in the field of anatase form. Okay. These are when I optimize this parameter at different voltage. Similarly, this is the time I did for a different time, and I optimize its parameter at 120 minutes, 120 minutes. I said it is better for my work. Okay. This is I check their capacity at different time interval. So its capacity is high at 120 minutes for 2 hours. Okay. This is for voltage. This is for also I use this at a different voltage, and I measure this. This was basically the optimization. When I was optimizing these were that experiment, and I published this paper. Second project, I try to enhance its specific capacity. So this was, I coated it with molybdenum trioxide, and that is optimization at different time, that how long I will coat this material on titanium dioxide nanotubes, and I found that for 2 hours, 2 hours, 6 hours, 4 hours, 8 hours, like this. I enhance this time, I increase this time, and I did it. This is after this time, a different time, I check these nanotubes as anode material, and I found that 4 hours have very good capacity. So I select 4 hours in my parameters. These are the nanotubes after coating and used in this is top surface, this is lateral surface. This is the electrochemical properties of lithium-ion battery for my anode materials. This is cyclic performance and efficiency. This is the rate performance, that how quickly you can charge or how fast you can charge a battery. Okay. Self-dop, this is third, and I used that same nanotubes. I just change its polarity in same, and I change its electrolyte, and I found that this have a reduction in titanium, and I use this in lithium-ion battery as anode material. This is published paper. This is its pristine nanotubes, and when I self-dop these nanotubes, and this is next. And in this, I need these titanium dioxide nanotubes in different environment, and I studied its effect. So in different environment, air, nitrogen, argon, and different Then this is crystal, this crystallite size was studied, and this is crystallite size. How with crystallite size, specific capacity of lithium battery is increasing, or anode material is increasing. This was study. This is scientific study, so maybe a lot of people will interested in this thing. If someone is interested in this thing, they can ask me. I have all this data and all these things. Okay? This is the 5th project, and in this I quoted titanium dioxide nanotube with molybdenum disulfide, and this is method that these are nanotubes, grown nanotubes, and this is coated nanotubes. This one is grown nanotubes, and this is after coating of this molybdenum disulfide material. This is their electrochemical properties, and this is published. In 2017, I joined Energy Center, Comsat University, Islamabad, Lahore campus. There we submitted different projects, and I won 2 projects. One is startup grant and 0.5 million, and other was the energy analysis of the energy storage material and systems for energy application, and this was 6.5 million. By these 2 projects, we established a very good lab in Energy Center Lahore, Comsat University Lahore, Islamabad Lahore campus, and still we are working with at this, and we are trying to further make our lab further better. We are also writing different projects for it still now. These are the publications with the Energy Center, Comsat University, Islamabad Lahore campus. These are publications in the field of lithium ion battery. Thank you so much for your attention. If you have any question. Okay.
Why Pakistani industry is not moving towards the usage or manufacturing is it the cost or the safety, or is this technology is immature? This is the first question. And the second question is there any chance that under CPEC, the lithium ion battery industry will move from China to Pakistan?
I think so. It will move. I give you this. It will move because without the efficient energy storage, we cannot move forward. So it have to move. First thing is that. Next thing is that our industry, automotive industry, basically dependent on lead acid battery. So most of battery we need is lead acid battery. So they don't want to. I think so. Industrialists don't want to spend money for this thing. Okay, but as this battery will go toward electric vehicle, and Pakistan will start electric vehicle system, I think so. Lithium ion battery, these industry will start lithium ion battery. So reason is that we are not going toward the electric vehicle. So yeah, because our consumption is storage consumption. We can get from lead acid battery. It is a little bit cheaper, and industry have not a lot of experience in this lithium ion battery industry because they have specific equipment and specific things. So I think so it is expensive for them, and they are not using this till now. But as we will start electric vehicle, okay, this industry will come in Pakistan, and they will use it. And for Pakistan, the countries like Pakistan, we should not move toward the electric vehicle like cars, small cars or big cars. We should move toward bi-wheeler and tri-wheeler. If we just move bi-wheeler and tri-wheeler, then it is enough for Pakistan till now. Thank you so much.
So this was Dr. Tasif Anwar. Thank you. Moving on to our next talk. Now I would like to invite engineer Dr. Ijaz Bashir Janjua. He's currently working as General Manager Research and Development at HMC Texila. He also served as Head Design Department and Head PMD. As GM R&D, he is responsible for the execution of research and development in hydropower turbines and its usage in the area of renewable energies. He is also currently working as member of governing body of Pakistan Engineering Council. He will share his thoughts on indigenous development of hydropower, future trends in renewable energy for sustainable development. Sir, please.
Assalamu alaikum. Thanks, Concert, to invite me on this toward the renewable energy resources. Today, my topic today is on the indigenous development of hydropower. As you all know that in Pakistan, we are abundant in the water resources. So my today lecture is, topic is to give awareness, the basic awareness of the hydropower development. I will not talk about on the statistical data, what has been done, but I will focus on for the students to understand what is the basic ideology and how we can get into the reality. So I will start my presentation. This will do of hydropower. I would like to see the future trends currently, for the future and the previous. Okay, next. As you know, Pakistan have a potential, hydropower potential. We have a lot of energy, but potential is that what we can tap it. So 46,000 megawatt, we are only using around 20% of the energy so far. So our speed is very slow. In that context, low head turbines are appropriate for majority of the micro hydro application. Why I said low head? Because from the high head, we have to arrange a lot of things, but on a run of river, on the low head, we can get the more energy, and that is more economical. Next. So introduction, hydropower is the energy derived from floating water. So we can get the power while the water is flowing or falling. It can be from rivers or from man-made installations. Naturally, we have a lot of rivers, but somehow, depending upon the locations, we have to arrange some man-made arrangements. We have to create some structures to perform this power output. The amount of hydropower generated depends on the two things, basically. One is the flow rate, and the other thing is head. These are the two basic parameters on which the whole hydropower is stands. Turbines placed within the flow of water extract its kinetic energy and convert into the mechanical energy. Next, please. So this is a bird eye view for the, and here you can see that Pakistan energy demand has grown at an annual consumption growth rate of 4.8%. Next, please. As all you know, from mechanical perspective, that CFD is a very important tool to utilize the hydropower. Unfortunately, in our universities or in our industry, there's no focus on this area. If you look at the foreign institutions or Chinese, which are giving us or selling us the turbines, that is not a big art. What I want to say is that if you have a number of sites over here, as an engineer, it's my responsibility to get that thing designed. And that design comes from the CFD, computational fluid dynamics. If I compare the model some turbine, if you look at the color of them, we have some model of that. But if you have a good hand from the industrial institutions of the academia and on the CFD, so it will save your time a lot. It will not save your time, but your investment. So without paying any penny, you can get your model testing. So you can play on that. And if you are done with that, so you will be at par with the foreigners, which sell us the turbines, which what we can do. This is, I am focusing on the young engineers to please make the things designed and applicable in Pakistan locally. So CFD analysis of the turbine parts is used for the design optimization. Design optimization means that we have to get the fully operative of the turbines, and that could be done by using this analysis. Yes, next please. So this is some list of the power plants hydropower energy is used. Next. So while we are talking about the roadmap to the renewable energy, so we must look at this roadmap also, which is very much on the higher side. So by the end of 2028, it's near, our demand is rising. But if you compare what we have done, it is not so promising. Next, please. This is, I want to show the basic terminologies used in the power plant. This is the reservoir. From there we can get the water. From here we get this is the intake, and there is control valve over here. From where we can control the intake of the water. So by the gravity, this water flows and hits to the turbine blades. There could be a number of different types of turbines. When it hits, it rotates the shaft, and through this generator, it is goes to the transformer and then goes to the other. So this part over here, this is known as the penstock. And here is the water is going out. So this penstock is very important. This is there are different types. In this case, this is under the building, but somehow, if we are talking about the high head turbines, so we have to take the water from very high level to the very low level. And for that, we need some pipe, and that is known as penstock. There is a pressure pipe, and its energy is very important. Next, please. मेरा हाथ लग गया इस वजह से. Potential, as I have already told you, that this is the figures. Canal system has a huge hydropower potential. Numerous sites location we have available in Pakistan, especially in northern areas of the country, are rich with hydropower resources. So we have a lot huge resources all over Pakistan. Next. Next, please. So what is the power? Basically, power is the product of, sorry, what was it? Again. Yes. The power is a product of, as I already told you, head and flow. So this is head and flow with the gravity. So this is the power. Here you can see head. For high head, we will have the low flow rates. For low head, we will have the high flow rates. So by that, we can differentiate that what kind of turbine we will use. Because both things can never happen, high head and high flow. Neither low head and low flow. So this is the ratio. Next, please. Based on flow path and pressure change, we can classify these turbines in two ways. Here, we are using the pressure of the water. And here, it is based on the flow. Flow means it could be axial flow, it could be radial, and mix of these two flows. Whereas, based on the pressure, we have the two types, impulse and reaction. Impulse is used for the high head, where reaction is used for the low head. Next. So, in the impulse turbine, as I told you, it is for the high head. Next, please. And reaction turbine, the pressure of liquid changes while it flows through the rotor of the machine. So what happens that water of pressure hits the area of blade, and by that conversion of mechanical energy to the kinetic energy to the rotor energy, it causes the rotor to rotate. And what I told you, optimization, that blade is of complex shape. So by creating that shape, we can optimize our turbine, and we can get the maximum output from the water available. Francis and Kaplan turbines are the most common names used for the reaction turbines. Next, please. These are main three turbines: Kaplan, Francis, and Pelton wheel. So Pelton wheel is used for the high end. This next. Next. So this is schematic of the Kaplan turbine. Here you can see the water is coming from this volute. If you look at the shape of the volute, it is, the diameter is changing, and when water comes from this through these wicket gates, so that water is controlled by these gates. Now the thing, as you know, if you look at the vertical shaft or cantilever beam, so if you look at this, this is the shaft, and this blade, this is acting as a cantilever beam. So when the water is hitting over these blades, it should be the equal amount of water should be drop over there. So for that equal amount of water to be placed over the blades, we need this shape, volute casing. The basic meaning of the volute casing is that the discharge of the water will be equally in the equal amount, so that the shaft could rotate smoothly, and there will be no effect of one force is higher on the one side of the cantilever and the other side is low, so it can create some problem for the shocks. So this is the basic criteria. Next, please. So if we look at the design of the Kaplan turbine, so Kaplan turbine is designed to accommodate the required large flow rates. And in this case, blades of the Kaplan turbines are not planar or any other axial flow turbine. Instead, they are designed with twist along the length so as to allow swirling flow and the axial flow. If you look at these two terms, swirling flow actually produces the power to rotate it, and the rest of the water of its component, there are two components, axial and swirl. So axial goes without imparting the work, whereas the swirling acts upon as a force. Next, please. So next comes the for medium head the Francis turbine. So its shape is different from the Kaplan turbine. In Francis turbine, flow is radial into the turbine and exits the turbine axially. Water pressure decreases as it passes through the turbine, imparting reaction on the turbine blades, making the turbine rotate. Major part of the pressure drop occurs in the turbine itself, unlike the impulse turbine, whereas complete pressure drop takes place up to the entire entry point and the turbine passage is completely filled. Next, please. So if you look at the design, so these are the shapes. You can, there are two rings over here, outer ring, inner ring, and blades in the center. Next, please. So third type, which is the head, is the Kaplan wheel. So it is not submerged in the water. So it acts with the kinetic energy of the impact of the force, impact of the jet. It rotates. In Kaplan turbine, water jets impact on the blades of the turbine, making the wheel rotate, producing torque and power. Next. Next. Here, the main parts are called buckets, where the water hits as a jet, and jet of water has a lot of power. In Turbella Dam, one of the gates was leaking. There was some leakage, and from that leakage point, the water acts as a water jet, and even it can cut out your steel. So it has so much power. Next. So other type is crosswalk turbine. It's a very simple design, mostly used in Pakistan and most of the areas. And we also at HMC we have developed one of it, and we have make it as tested over there. We designed, manufactured, we got its CFD analysis, we got the good results. We got its RPM was very good. So we used using on the water tank over there. So we perform testing over there, and we produced a load of 4 kilowatt over there. It was 250 kilowatt turbine, locally manufactured. Next, please. When we are going to design, so we need some criteria. We need some quick references. So next, please. Here's some chart. You can see over here, if the head is high, but the flow is low, it is the impulse turbine. If you look at Francis turbine, its head is bit low, but the flow rate is high. And if you look at the impeller or Kaplan turbine, low head turbine, reaction turbine, you can see the head is very low, but the discharge is very high. So from this chart, we can figure out what kind of application can be used in our site where we are going to work. Next. So now we'll talk about some design parameters. Next. For these turbines, we need a lot of structure over there. That how we will tap the water, how we will control it. So there are a lot of important steel structures for the hydropower. So hydraulic structure is a structure submerged or partially submerged in water which disrupts the natural flow of water. हमने नेचुरल वाटर की जो फ्लो है उसको डिस्टर्ब करते हैं अपने काम के लिए. So one canal is coming, so we will divert it to the other path by putting our power plant to the other side. The whole power water will come back to that canal. So there is no wastage of water, and we are going to take advantage of that. It can be built in rivers, canals, or any body of water where there is a need for a change in the natural flow of water. Next, please. Next. So these are some components of hydraulic structure. Stop logs, hydraulic gates, trash racks, and penstocks. Stop logs are used to control the water if we are going to have some maintenance of the turbines. So we can stop as the name shows, stop logs. In the old days, these were made of woods. So they gave the name of stop logs. Now it is a steel with a steel structures and controlled by, you can control it by your cranes or something else. Gates are very important for the, if you look at the Khanpur Dam, if some floods come, so you must have those gates over there, so we can open it up and we can step into the dangerous. Trash rack is very important. This trash rack, when the trash rack comes, it will reduce the power of the water. So we have to remove that trash, right? So for the removal of that, TRCM is used, which is the trash rack cleaning machine. Penstock is very important to get the water from the high level to the low level. If you see, if you are not using the penstock, and how will we get the water from the lower side? So the diameter of the penstock should be economical because you have to take it on the mountains. So that's why it's the way the less will be the penstock dia, less will be the your flow rate. But that is very high. Next. HMC being the largest industrial unit in Pakistan have the most adequate facilities and skills for the design and manufacturing of the hydropower components. Having capabilities and skill available, HMC have completed several projects of hydropower sector in Pakistan. For hydropower development, HMC has all the facilities which can be used. So these are the facilities which are necessary for the manufacturing of these turbines. Here we have the design and engineering, which do all the designing for the turbines. Next, please. So here I would like to show you the analysis flow of the turbine. Here you can see first it was in Pro-E or Creo, then we make use of software ANSYS, which is called ANSYS. ANSYS, there is a CFX module which is used for the CFD analysis, and then after that model we can get the meshing. So for the meshing, we need independent study of the that part, that your meshing should be so enough that it can take a good results of your analysis. Then we apply the loads and then we get the results. So this is the blade. This was the blade where you can use. Yes. Here you can see the blade meshing, its analysis. This is the static analysis, not the CFD. Okay. This is just static analysis at whether this blade is okay or not. Next. Here you can see shear stress zone and the maximum deformation over here. And here you can see the maximum shear stress zone. Next. इसको play कर दीजिए guys. इसके ऊपर click करिए. Here you can see the two colors. One is pink and the green. So the top color is for the high pressure, whereas green shows the low pressure. And by the difference of these two pressures, we can get the energy. Next, अगले पे play करें. This is how in CFD we can use the velocity vectors. Here you can see this is the blade over here, and this is the domain where you can use the CFD path of the water working on it. Next. This is the turbine which we have locally designed, manufactured. What was the basic objective of this? In PIDO, in northern areas, there are a number of sites available, and they allow above 100 kilowatt to import from the China. So for that, to show them that we can do it, Pakistan can do it, we designed, manufactured a 250 kilowatt turbine. We prepared a test bench over here. We tested it. We get the good RPM of the. If you look at this this pulley, here we got the 180 RPM, and output was 750 RPM. And we tested it. We put some grinders over there. It was, I think, 4 kilowatt load. It was tested, and there was no vibration. And now our plan is to get this turbines into the northern areas, and we are looking for the potential buyers. So this is what an engineer or we must do it. I want your attention to this point, that we can do it as a Pakistani. Why we are depending on the others? आपकी जो रिसर्च है उसका कोई आउटपुट होना चाहिए, शेल्फ में नहीं जानी चाहिए. So here I put the name HMC with the bulbs, so it was generated over there. Here you can see this is the outlet. So water is coming from this tank. Renewable turbine going back to the your first. एक इसका हमने बनाया हुआ था, पॉन्ड बनाया हुआ था जिसमें से वापस रिसाइकल होता है सारा. Next. Here, this is how we can perform its analysis. This is the rotor, and here we perform, and you can look at this. If some of you are familiar with the CFD, computation fluid mechanics, you can see that this water is coming without any breakage to breaking to the your rotor. Next. Here are some types of small turbines. This is in northern areas we supply to this turbine. आगे चलते जाएं. This was the Ghazi Broda drop tube. Basically, this drop tube is for the water flowing out from the turbine, and it controls cavitation. Cavitation means that you have due to which I told you last slide, high pressure, low pressure. Because of that high pressure, low pressure, there are some bubbles created, and because of that difference, when they are exploded, they work as a bullet. So it hits your structure, and the material is eroded. Even if it is of stainless steel, it is eroded. So to avoid that eroding, to avoid that cavitation, we use this drop tubes. These are the liners, the penstock. This is the volute, which I already told you that the purpose of this volute is to provide the water in equal amount to every blade of the turbine. Next, this is the Kanpur Dam gates. Radial gates. Its size was around 13 meters by 11 meters, and since long it is working very efficiently. But I want to say that in Pakistan, we can manufacture and design a lot of things. That's what is our roadmap. Next. These gates we have we are exported to Afghanistan. So it is also, this is for the irrigation purpose. Next. These are the process turbine which we have manufactured for the Dargai power plant. Next. This is the penstock which we have designed, manufactured, analyzed for the Malakanti hydropower project. Another contribution. Next. Here comes the real contribution of Pakistan. In Nadipur plant of hydropower plant, there are 3 units of 4.6 megawatt. So it was built in early 1960s. So one of units blade was broken. We went over there. We took it as a challenge. So we said that we can manufacture it. So we casted. Manufacturing was through casting, and we took one blade from them, and that was similar casted over here. And for the last, I think, 13 years, it is efficiently working over there. So by doing that thing, we have saved a lot of money, which was going to the farmers. It was in Nandipur, and its tonnage, the weight was 2 tons, whereas if you make casting of it, then you have to put a material of 4 tons, so that your impurities should come up and you will get the blade like you can say forged material. Next. What benefits we can get? Does not potentially cause the submerging of the forest. So it's थाना के काला बाग में ऐसा डूब जाएगा, तो वो ऐसी बात नहीं है. Generation of hydropower produces no greenhouse air pollution or any waste products. Energy in remote and hilly areas where extension of grid system uneconomical. We went in Khoistan, Upper Dir, so their local community is using that power, that energy by their own resources, and it is very well be achieved for their homes at their own. So by doing this, the non-polluting and small scale irrigation is there, and small scale agriculture industry, rice and oil mills, wood industries, saw mills. Even in Kashmir, if you look at some sites for the stone crushing, they can use hydropower energy to run that industry. Next. So what is the future perspective? ऑप्टिमम यूटिलाइजेशन, मतलब आपकी जो लोकल मैन्युफैक्चरिंग है वो ऐसी नहीं करनी है, आपने उसको ऑप्टिमाइज भी करना है। Participation of local industry, vendor development. When we will make locally, we will develop our own vendors. Rapid growth in mini, small hydropower plants in the country, gearing up for production of medium, large sized hydropower plant. ये हम फ्यूचर में भी कर सकते हैं. Saving in foreign exchange expenditure is very important. Next. So this is a conclusion. The only solution to meet such a high demand and considering the water as renewable source, hydropower energy can be the best solution to the current problems as well as the future energy crisis. Swati, thank you. Next. Thanks, sir. Any questions, please?
Tell us some of the sites. The run-of-river turbine manufactured by Lithium Ion start.
Actually, as I told you, Dargai hydropower plant, Francis turbine, Dargai. No, but that was your that is the one I told you, blades for the Nandipur. But that this is on the run-of-river. This turbine blade I have showed you, the Nandipur. Actually, the problem is that to make a complete hydropower project is a different story. Making the parts is another step. What we are doing, we are manufacturing, producing most of the parts which are related with the this hydropower plant. What I told you, Nandipur, it was a blade manufacturing by HM. This is contribution toward the power plant because otherwise one of their unit was not working. So that is so as far as you said, the complete hydropower project, that is not the case. We are running nowadays. We are doing two projects. One of is Naltar hydropower project in Gilgit, and the other is Jagaran hydropower project, 48 megawatt, and Naltar is 16 megawatt. No, that is run-of-river. Run-of-river means that you in far areas, high end, we create our water in the pond. But as far as you said for the run-of-river, there's no such projects coming. It's all high areas. That is the application. Run-of-river, basically the thing is the turbine. Rather is a run-of-river or it is a high-end. The main purpose is your turbine. So as far as I told you for the low height turbines, sorry I missed one thing. We are working on the development of Kaplan Turbine 35 kilowatt. The same will be utilized over which was the Crosswalk Turbine, which we have manufactured. We are working on that, and after that, we will utilize it for the river industry.
What is the main challenge in designing turbine? Is the material used?
Material, no, not the challenge. Material you can, we have the metallurgy available. The issue is with the design. There are two things. One thing is the product design, the other is process design. In product design, as I told you earlier, we can design the complete turbine depending upon its flow, as I told you, head and flow rate. These are the two parameters. And whenever you go to any new site, you will get the parameters and you have to design that. And for that design, you need some computational techniques, which are the CFD. So what I am focusing at the university level, CFD or in the industry, has not been encouraged because it is a very tough topic. So if we are capable to get the CFD analysis, so I think we can design anything.
Implementation easy after CFD design.
Yeah?
After CFD design in simulation, then its implementation in hardware and physical is easy.
Yes, yes. अच्छा CFD के लिए भी मैं उसको ये बता दूं कि CFD के लिए जरूरी है कि you have to first validate it. First, we have to the things which I told you about the Nandipur blade. When we design it, make CFD analysis of it, we got the optimum design of that, and for that, the data of that power plant was validated with this CFD analysis first. If you are validated, data is validated what you are doing, then you can perform further optimization. That is very best tool because there is no financial impact of that. There is you can make a lot of attempts and you can get it. Not over hydropower, but your CFD can be done in any other case. Any other, please?
Sir, I'm Dr. Desiccant Wheel, representing JIK Institute. First of all, I will really appreciate that you have highlighted the importance of CFD, and let me share with you that at JIK Institute we are not only covering CFD at the course level but at the lab scale. We have the licensed version of this CFD tool. And my question is that is HMC is fabricating, manufacturing the wind turbines or only this hydro?
Wind turbine.
They are all,
Okay.
you are all.
On the wind turbine, it is our new first target is wind turbine, and we are going to have some MOU with one of Sander companies of Spain. So we are going to have a MOU with them. Already is in the process. So I have visited Jampir in Karachi. So there are a lot of turbines, and there's a need of for their actually there are the main the thing is blade. Their blade is of a composite material. So for that we are going to with this our MOU, we will we try to make some arrangements in Pakistan for this manufacturing of these blades. That is other thing is a mast, which is very we can make it manufactured easily. But the main thing is the blade, composite of it, with composite material. So in Jampir, its size was very high. So in Kalarkar and Peshawar, we have a very good wind zone over there. So we can also make some blades with a small sizing. And the blade, its life fatigue analysis is very important. Fatigue analysis that how many cycles it can bear. So our next target is the wind turbine.
How is the status of modern manufacturing equipment there?
CNC is, can be used, is a very important tool for manufacturing of this. As the shape of the blade is very complex, as you see over there, so we are trying to get it from the 3D printer.
Because these days in industry, almost every manufacturing, cutting, welding, drilling, patterning is being done with laser-based system. So you have some laser facility?
No, in HMC, thanks to China that they have given us this big company early 70s. So we are using the old machines, but with old machines we are getting a maximum benefit of that. So as you said, all the things has been done by the laser cutting. Yes, we are using it. If you see our Crosswalk Turbine, there was some plates for the shaft, and the shaft design is like it was a step design. So it was very important to cut it the disc into two sizes and put it to the desired point. Now, suppose this is your outer diameter, you are coming and decreasing, okay? So you can't put from this side one, so you have to put in two halves and join it. So we, using the ADM, we cut that plate, and it was, when we joined it, we saw that there is, it was same as it is the whole disc. And the other thing is for the manufacturing, for the pattern making, our next target is the 3D printer. We are customizing it. We have the 3D printer, but now we are customizing it to make the big size of the blade because it's have a complex shape. And then we have a casting with that part. We will be able to. And after that, of course, when you need some finishing, you can use the 5-axis CNC machine.
Assalamu alaikum. Thank you very much for such a nice and informative presentation. So my question is about the maintenance side of this, like when you talk about sustainable energy or sustainable technologies, maintenance is very important. So, but do you have any opinion about the maintenance of heavy machines or like wind turbines or in your case, hydro turbines? And what we at academia can do, because currently I'm working on a series of fault diagnosis techniques which are relevant in heavy mechanical side. So, so I would like to know what kind of systems you have and how we can contribute in this on this particular side, because this, in sustainable technologies, maintenance is very important. The detection of fault, or rather prediction of faults, because when you talk about a machine, it's important that a heavy machine, it's important that we predict the fault before it even occurs, because if the fault has already occurred, then the machine is inactive for a longer period of time, and it takes a lot of time to restore it, and it's apart from wasting time, it's power generation and everything stops. So can you guide on that, and please
thank you. You have a multiple questions.
Okay, thank you.
First is sustainable development. What we know about what is sustainable? Question is, what is sustainable? हमने हॉकी का मैच जीता, उस वक्त जो उनके जनरल साहब थे, उन्होंने कहा जी कि अब आपने खुश नहीं होना, नाउ यू हैव टू सस्टेन इट। कामयाबी तो मिल गई है, लेकिन अभी आपने इस पे, अब ये होता है कि प्लाट दे देते, फलां को ये कर दिया, फलां को ये कर दिया, अगले साल फिर जीरो पे आ जाते हैं। तो डेट सस्टेनेबिलिटी ये है कि आपने जो काम किया है उसको अपने आगे लेके चलना है, पहली बात तो ये है, और उसी क्वालिटी के साथ। देन योर नेक्स्ट क्वेश्चन वाज दैट द मेंटेनेंस ऑफ द heavy parts, what we have the arrangements. Okay, if you design something, so first of all you will make the maintenance free product. अगर आपने गाड़ी में देखा होगा, एक सुजुकी में लगा होता है फिल्टर, तो बड़ी मुश्किल से जाके वो लगाना पड़ता है, तो उसकी मेंटेनेंस के लिए उसके ऐसा है ना, वो अगर प्रॉपर्ली डिज़ाइन किया होता तो आई थिंक उसके लिए वो बहुत जल्दी उसको आप ठीक कर सकते हैं। तो जहाँ तक मेंटेनेंस की बात है, तो उसके लिए यस वी हैव, बल्कि अभी मैंने बात की थी कि HMC चूँकि हमें चाइना से गिफ्ट मिला हुआ है, तो वी हैव ए लॉट ऑफ मेंटेनेंस प्रॉब्लम्स। हमारा काफ़ी सारा एसेट्स जो है वो मेंटेनेंस पे गुजर जाता है। ठीक है, अच्छा एक और चीज़ आपकी रह गई थी कि प्रोडक्शन की जाए कि चीज़ जो है वो कैसे ठीक होगी। उसके लिए प्रोडक्शन condition monitoring is a very good tool, and for that we are having some project with we have submitted an NRPU project. It is still under review with the BEC Wajni College. So that on that prospects we are working on that.
थैंक यू। तो इसमें सर हम आपके साथ कोई कोलैबोरेट कर सकते हैं?
Sure, you are welcome. आप यहाँ से जो भी हैं, you are welcome to visit, see, because seeing is the believing. मैं एक मीटिंग कर रहा था प्लानिंग कमीशन में, तो वहाँ पे जो मेंबर पावर थे, ये सर जी जैसे दरगाह की बात हुई है, वो जी आपने तो दरगाह का बनाया था, उसे काम नहीं किया, मैंने किया। मैं सर आप आएँ, जो आपको इन्फॉर्मेशन मिलती है वो प्रॉपर नहीं होती। मैंने कहा आप यहाँ बैठे हैं, इस कमरे में निकलें बाहर, ये 40 मिनट की ड्राइव पे है, आप आएँ, see the things and then we can talk. वो दिन आज के दिन वो नहीं है। बात होती है कि आपको बिलीव, आपको जब तक आप चीज हाथ से काम नहीं करेंगे, आप इस चीज को देखेंगे नहीं, तो आपको उस चीज का अंदाजा नहीं होगा।
तो सर ये जो आपकी जो हैवी मशीन्स होती हैं, इन पे कोई वाइब्रेशन सेंसर या कुछ तरह की चीजें इंस्टॉल्ड होती हैं जिनसे डेटा आप एक्वायर करते हैं और उसकी बेस पे फिर एनालाइज करके
असल में हमें इतना टाइम नहीं मिलता कि इतनी प्रोडक्शन का ऑर्डर होता है कि यू हैव टू क्या कहते हैं कि आपने उस टाइम पे उस चीज को देना है। जब मेंटेनेंस हो रही होती है, ज़ाहिर मेंटेनेंस हमारी वैसे हो जाती है, कुछ चीज टूट गई उसको सही कर लिया।
वो तो मैनुअल मेंटेनेंस
एक होता है ना कि मैनुअल होती है, एक होती है आपकी रूटीन में होती है, एक कुछ अर्से के बाद प्रोडक्टिव उसको कहते हैं मेंटेनेंस का। जी जी, तो सर शेड्यूल तो वहाँ बनेगा ना जब यहाँ पे आपकी नई मशीन हो, ठीक है, जब आपकी मशीनें आपकी वो अपनी लाइफ भी पूरी कर चुकी हो।
नहीं सर, I'm actually talking about condition monitoring.
Which
one, the one you just mentioned?
Exactly. के लिए we are using a platform of NRPU, and that another university is collaborating with us. अगर वो हो जाता है सक्सेसफुल, तो वो हम उसके तरफ जाएंगे, उसमें हमारी काफी सारी बचत हो जाएगी। मतलब कंडीशन मॉनिटरिंग आपकी मशीन्स के ऊपर भी काफी सारी, आपका जो आउटपुट पार्ट होगा, that will be very effective.
Okay, thank you, sir.
Welcome. Any other? टर्बाइन में टेस्टिंग फैसिलिटी तो आपकी वो है आरपीएम चेक करने के लिए, उसको हम करते हैं जी, ये टॉर्क वगैरह चेक कर लेते हैं, उसमें वो फैसिलिटीज अवेलेबल है वहाँ पे। बाकी आपके जो क्यूए के अंदर जो भी आपकी एंटिटीज की टेस्टिंग है या दूसरी, वो सारी अवेलेबल है वहाँ पे। Anything else? Thank you. Thank you. Thank you very much.
Okay, it was some very interesting hardcore engineering we have seen. It was Engineer Dr. Ejaz Bashir Janjua Saab. Now I would like to request Professor Dr. Laik Khan Saab, Chairman, Department of Electrical and Engineering. Sir, please present souvenirs to our respected guests. I would first like to, sir, and along with him is Dr. Kadir Hassan. First of all, I would like to invite Professor Dr. Nadeem Ahmed Sheikh Saab. Next, I would like to invite Dr. Tosif Anwar from the University of Lahore campus. Thank you. Next, I would like to invite Engineer Dr. Ejaz Bashir Janjua Saab from HMC Texila. So this makes us come to an end of our morning session. I would like to request join us at lunch. And I would also like to request all the participants, as we have all the speakers coming from different parts of the country. So take this lunch as a networking opportunity as well. Just very rarely we see these faces around. So please join us at lunch, and we will commemorate in this room again at 2 p.m. inshallah. Thank you very much.